Right, welcome to this video on linear programming as it's tested in F5, in which we'll cover all the areas that you need to be able to cope with, mostly by following through an example and then trying it on some exam questions. So, linear programming is when we have limited resources. And there's various possible situations, which I've listed down here, which describe what method to use in each case. So if we've got just one limiting factor, like say material or labour, or something like that, multiple products, 5 different products, then we can use key factor analysis or limiting factor analysis, as we've looked at in another video, in order to decide how to maximise our profits. Of course, remember that when we try to maximise profits, what we actually do is maximise the contribution and leave the fixed costs out of it, because what we're going to be continually doing is saying, I'll do one more of that product, one more of that product, and what we don't want to be doing is assuming that the fixed costs are increasing. It's only the variable costs and the sales revenue increasing, so it's just the contribution which we look at. But by maximising the contribution, we will maximise the profits as well. If there's one limiting factor but multiple products and we could subcontract, then we have the make or buy scenario or decision to make. If there's 2 or more limiting factors, so we've got material and labour and machine hours maybe all restricted for what we want to do, and only 2 products, notice just the 2 products, then we can do linear programming using what we're going to do, which is a graphical method, using a little graph. So we'll need a ruler. So if you haven't got a ruler, stop the video now, go and get one. It's going to help. Or maybe we have 2 or more limiting factors and more than 2 products. You'll be glad to hear that that's outside our syllabus. We can't do a graph for that one, because otherwise you'd have to do a 3 or 4 dimensional graph, which is quite tricky. It's algebra, it's algebraic, it's an algorithm called the simplex algorithm, and that is outside our syllabus. So no need to worry about the one. So we are looking at this one. So a bit of a recap, just in case you haven't done it for a little while, on single limiting resource, just a quick recap example before we dive into linear programming. So we've got a question here. Fish Limited produces flippers and fins as follows. Per unit, flippers and fins, sales, skilled labour, unskilled labour, direct materials, variable overhead. We can therefore see the contribution on each one. On a flipper, 32 minus 12 minus 5 minus 3 minus 10 gives me, I think, $2 contribution. And a fin, 45 minus 15 minus 15 minus 3 minus 5 gives us $7 contribution. And we can also see the skilled labour hours are 2 and 2.5 in the flippers and fins, although actually we could have worked it out from that line, so it's just been quite kind to us. We could have divided by 6 and got 2 and 2.5 hours. We've got a maximum of 18,000 skilled labour hours, and demand for flippers and fins is 6,000 and 5,000 respectively. So what do? Here's the flippers, here's the fins. So contribution per unit we've worked out as being $2 and $7. The skilled hours per unit needed are 2 and 2.5, which means the contribution per hour is $1, and 7 divided by 2.5 is 280. Which means in terms of order, I'm going to do that one first and then that one. So the hours we actually have available are 18,000. So the first thing we'll do is make all the fins that we can. And maximum demand for fins is 5,000. They use 2.5 hours a piece, so that is 12,500, which only then leaves 5,500. How many can we then make for 5,500 of the flippers? So divide that by 2 for 2 hours per unit, and we get the same business. So one way to set a price is to identify what the costs are and then add a margin on top.